Okay, so tonight we are going to be talking about Chapter 1, Introduction to Networks. And last week in the discussion, I always like to start out and ask you guys, what do you guys know about networks? Just kind of explain your home networks because a lot of people know a lot more about networks than they give into. So that was just like a little icebreaker. And now we're going to talk about networking themselves. The objectives for this week is distinguishing between the different client server network and a peer-to-peer network. We're going to break down those topics as well, identifying the types of applications and protocols. Protocols are just different types of languages that the computers talk back and forth to make sure that the information is flowing properly. And then we're going to describe different type of network hardwares and different topologies on the network. Um, then we're going to get into the OSI model. The OSI model, we're going to break the ice on it this week, but going forward, the OSI model will always be a key factor in networking. It's just a model to help you understand theoretically how data flows and how data transport from across the network from one PC to another. This is something you should definitely memorize the steps in the OSI model. This is something that you will possibly see on the CompTIA examination. And then also you'll see it on some of the quiz questions going through the rest of the semester. Okay. Then we're going to talk about some best practices for safety and troubleshooting. Troubleshoot is always one of my favorite parts of networking because it seems like it's just so easy. So one thing in networking classes, there's going to be a lot of acronyms. So a lot of acronyms. So for you guys to just get used to those acronyms, sometimes we'll say topology or you say a network operating system, or you might hear NOS. So on your quizzes and on assignments and stuff like that, sometimes you may see acronyms, and then sometimes you may see the full language out. My way of learning is always when I see the acronym, even in the book, I try to say network operating system, not just NOS. So definitely as you go forward, look at the glossary terms in the back of the book because there are a lot of acronyms in networking. So we'll talk topology. Just how parts of our network work together. And then you got the physical topology, mostly applied to, hardware described, it's computers and the physical pieces of the network. And then you got the logical topology, which is the software, how software transports on the network itself. Okay. So those are a few different things. Peer-to-peer network or P2P networks. The OS or the operating system for each of these computers. This is kind of how they talk and how they connect. And there's going to be diagrams that's going to show a peer-to-peer network. So in a peer-to-peer network, there's no centralized control. So basically, we go to the next slide here. So this is a peer-to-peer network. And as you can see, each system for them to communicate has to be tied to each system. This network is not too practical. This is in the very early stages of networking. And everybody had to have a handshake. Everybody had to be physically connected. Okay, so no computer has the authority over another computer. Each computer controls its own resources and communicates directly with the other computer. So that's the advantage of it and some of the disadvantage of it. The advantage of it: simple configuration, less expensive. Um, the disadvantage, and this is one of the main reasons why they went away from it, it's not scalable. You can't upgrade. It's kind of hard to grow from a peer-to-peer network. It's very costly. So we have to go away from that. So new things came out. So they started coming out with a client server network. And client server networks are networks where you have clients. A lot of times the different computers on the network are considered clients or nodes. And then they communicate with the server. Okay, the server kind of controls everything other than the peer-to-peer networks. Okay, so resources are managed by the network operating system via a database. It's usually put on a domain, a logical domain of computers. You have a server that controls everything. We call it Active Directory. So the Active Directory server controls all the computers on that particular domain or group of computers, and you can break them out into different domains, or like different little pods or categories. You can break them out into. So that's kind of how they grew away from the peer-to-peer, and that's one of the evolutions is a client server network. Okay, so clients, the computers that request, a computer makes a request from another computer. Uh, Clients don't share their resources directly with each other. Um, Access is controlled by the centralized domain database. Client computers access resources on the other computers by way of the server. So the server is really controlling everything else. And this is a very good picture of a client uh, server domain where you have the server in the middle of the database, and then you have your laptops, you have a network printer. So all these workstations here, in order to print to this printer, we have to go through this server to get over to this printer, and it's probably have a print server on here, program on here, which allowed them to go to this network printer. So that's kind of how it works, and it's kind of scalable in that regards. Okay. The NOS, or network operating system, is responsible for the following things. It manages all the client resources and ensure authorized users are on the network. So it controls the files. It restricts different users from different access. So the operating system has all the control, and that's very important because you want to have security, and you want to have the proper security policies in place that people just don't get on the system and just go all throughout your network and cause different problems. Or you do not want to have, say, for instance, a financial institution. You want to have all the financial data, payroll data on a separate domain or a separate party segmented out on your network versus people who are doing, say, the accounting work, or say if it's a manufacturing firm. You don't want all the engineers and those guys working on the system, and then they still have access to payroll. Two separate segments, and you want to restrict different things of that nature. So these are a few different servers on the bottom there. Windows Server 2016. This slide deck is a little old, can be updated. Ubuntu servers, Red Hat, and you have the different Linux servers as well. I personally have never programmed a Linux server. I have worked with Linux, but I've never programmed one of their servers. Servers that have a NOS installed is required. They have to have more memory and more storage capacity because they are the server. Equipment with several hardware provided network management functionality. The advantage relative to a peer-to-peer network, user credentials are assigned all in one place. So you don't have to go to each computer and sign them. You just sign them on the domain, and the domain controller will just send them all out everywhere. Multiple shared resources are going to be accessed from the server, and it's centralized problem monitoring. So that one server can monitor everything and all the activity on the network. So there's a lot of advantages when you have a server on your network. Now, a lot of people in their home and things of that nature, you don't need a server. That's overkill. Unless you are a photographer and you are a videographer and you're doing huge data sets and files and things of that nature. But it's always interesting when I see the students say what type of network they have. Some of the ones who are gamers, and some people just want to build the servers and things of that nature. I have a 1 terabyte hard drive, or a couple terabytes hard drive, and I'm not even close to filling it up. And I work in the IT for a living, so I'm always curious to see what are people saying. Client server applications, you have network services. The resources a network makes available to the users include the applications and the data provided by these applications. Then you have the client server application. A client computer requests data or a service from a second computer called the server. And then you get the protocols. That's the method that rules communication between the different devices. Okay, you always have different protocols. Now, two protocols that you guys are gonna get very, very familiar with is the TCP protocol, with the transmission control protocol, and the IP protocol. In the computer industry, they went a long route. They went through a lot of different areas to find the proper protocol for networking to work. Then they came up with the two best ones, the transmission control protocol and then the internet protocol. These two protocols combine. A lot of times we just say TCP IP. That's just in the industry. You say it so fast, but you forget sometimes though, these are two separate communication protocols, okay, that the OS use. So here's an example here. So you're sitting at your computer, you open up a web browser, okay? It's going to do going through the internet to do a request over the internet. It hits the web server of the place you're trying to locate, and then the web server will send you back the requested page that you're asking for. And that's basically how computers work. The IP address um, is associated with a name um, of the client that you're trying to reach, whether it's Yahoo, Google, Facebook, or Amazon. Uh, Computers work in numbers, ones and zeros and numbers. But if and every computer has an address. And I may be jumping a little ahead, but the theory is, we translate those, we resolve those addresses, which we call IP addresses, to name resolution, because it's a lot easier for me to remember. I'm going to Best Buy. I want to purchase something from Best Buy, so I'm gonna go to bestbuy.com. Then to what is Best Buy's address? 256.834.299.15. And then you got the other company. It's a lot easier. So that's the reason why they translate that. So that's just a little ahead of the time, but we'll get to that. Um, List of several popular client server applications are web servers. You have email servers, FTP, which is file transport servers. Telnet, that's where we jump on. Um, we could jump from one computer to another. We have remote applications and remote desktop. You probably heard a lot of these terms in the past, and we're going to kind of talk about them. But these are some of the things that a client server application can do. Okay, so if you're sitting at your desk here, SMTP, you're trying to send some mail. You send the mail to the mail server. So total completely different server. It gets the mail, it sends it out, it receives the mail. Then depending on what type of mail it is, it's going to use which protocol, which is the POP3 or MMAP4 protocol. So SMPT is used to send mail to recipients and email servers via POP3 or MMAP4, which is used by the client to receive the emails. So that's basically what's happening when you're sending your emails. Okay. So I don't know if these slides are kind of small here. Let me see if I can blow up this a little bit here. Okay. I'm on my small monitor. So this right here is just using a remote desktop to access computer from one computer to another. And basically they're just showing you how to do that there. So we'll pass on that slide right there. Network hardware. Local area networks, or we call them LAN because they're local, usually consists of small spaces such as an office or an office building or your home. Those are small LAN networks, okay? And in a small LAN network, there's a few pieces that you need to keep your small network up and running. One of the pieces is a switch, and that's which is receive data from one of its ports, and it redirect that data to another location or another port. Okay, so you definitely need a switch. Um, a lot basically this is you're saying that a lot of local LANs work in a star topology. So if you think of your home network, all devices connect to one central device, which is usually a switch. Usually in most homes, you only have one switch or one router in your network. A switch and a router can be interchangeable, but switch is really dumb. A router is smart. It's a little bit smarter. But uses a star typology. And then you need a NIC card. We call them NIC card, network interface card. These are cards that you plug the cable in that looks like a phone cable, which is really an RJ45 cable. That's a network. It plugs into a network interface card. So a lot of times you see those on your on the side of certain laptops. A lot of new laptops nowadays are just strictly Wi-Fi. They don't even have network cables, network cards, but it's still a star topology. And you can see why this is called star topology, because the switch is a central hub or port of the network. So you got your laptop coming in, Windows computer, the network computer, you got a Windows server, everything is plugging into one central location. Okay. And then that's the reason why they kind of call it a star topology. Even though physically this might be upstairs, this might be downstairs, this might be right next to this computer here, this may be in one of the bedrooms or whatever else. But in theory, when you write it and you draw it out, it looks like a star. Okay. These are just different types of switches that you see in the industry. So basically, these are more industrial size switches. You should probably never see any of these in your home. But in the past, when we would go to the tour of the data center, the Islamic College data center, you could see these type of industrial, more larger type switches there available here. So as I was stating earlier before, a laptop. See right here, this is your network port here. This is where the cable plugs in. You know, my laptop don't even have a cable in anymore, but most people plug into ports like this on the side of their laptop. Um, this is a network card. Usually you see these on the larger desktop computers, the gaming computers, the big PC towers, and they plug these into the network. Now, Wi-Fi is great. I love Wi-Fi, but it's depending on what you're doing. If at all possible, and when at all possible, it is my professional opinion to always plug into the network. If I do a lot of video work, I do a lot of video streaming and things of that nature. And when I'm doing recording or if I'm producing a program, I never go Wi-Fi because it has a lot more latency. It can mess up the video production. And if you drop from the network your program, which is live, now if I'm say at a little league football game and I'm trying to stream it or something like that, yeah, you may not have a choice. But when all is possible, as much as you can, always plug if you can your system into the network, and you have a lot better response. You just want to cut out all the variables. A LAN can have several switches. The backbone, a central conduit that connects the segment or pieces of the LAN together. And I'm gonna show you a backbone in the next slide. Sometimes we use a higher transmission speed and different cables to connect that together. Um, Three switches daisy chained together in a single line is said to be called a bus. So, and they said, well, however, a switch can be connected to a computer via star topology as well. So if we look at this slide here, basically this line right here in the middle, this yellow line here, this is the backbone because the three switches here are connected together. So this is the backbone of the network. Okay. Excuse me for a second. Got a little scratch in my throat here. Okay, so that's the backbone of the network. Now, what you see also here is the fact that this is also a star topology. So the slides here says three switches daisy chained together in a single line is considered a bus topology. So this is a bus. So this is the backbone, but three together consists of a bus. Okay, three or more. Really, it's three or more. Okay. Now, although this switch here has these four computers on it, and this has three, and this has three, these four computers are a star topology. Remember, they're all plugged into this one central location. This could be on the second floor, third floor, first floor, second floor, but it's still considered a star topology because they're all plugged into this one central switch. Excuse me. And the same is for this one, and the same for this one as well. Hopefully that makes a little sense for you guys. Okay, router. That's a device that manages the traffic between two or more networks. Okay, it can help find the best path for traffic for the network to flow through. Route can be used in small networks or in LANs. Okay, in your home. So a lot of times we call SOHO, small office or your home network. That's what you guys at home. That's the SOHO network. Nobody really used that terminology, but that's what really is considered. Okay, if you have a real estate office and you're the only person, then that's what it's will be called. Industrial grade routers can have several network ports for each network to connect into. And the difference between a router and a switch, a router, and this is a very important concept here. You may see it on some quizzes, so just think about this. A router is like a gateway between a network. It belongs to two or more logical networks. A switch belongs to just its own logical network. So here, this would be considered a switch because it's just its own little network here, but I don't have a picture of a router. Let me see if the next slide shows. Oh, okay, here we go. Perfect. All right, so a router switch, but this is a router, this right here. So you see the switch right here? You have a switch here, but then you have your home router, which is going out to the network here. So a router stands between a LAN and an internet. So if this was going to connect to another network out here, that's why you use this router. But you have this switch just inside your house or your home office here. Okay. So a combo device, and a lot of places are going to these. They're switching and routers together. So this device here eliminates these two together. So it's functioning as a switch and a router. This is a little bit more smarter, and this is what you see even with the Comcast and Verizon and things of that nature, like that or whatever. When they send you those ports, so your internet provider, a lot of times they're sending these combos. Okay, but that's the difference. So the switch is just your own little network here, but then the router is going to connect your network to another network. It's going to connect your network to another network, and it's going to use the smartest path to get your data across. Okay, hopefully that makes a little sense. All right, so here's another picture. What do we have here? So we have three LANs connected to one router. So you have three LANs. That's a switch here. You got a LAN here, switch here, LAN here, switch here, LAN here, all in a star topology. This is all star topology connected to this one router. Okay, so what did I say? A router will connect your network to another network. So you have your network here, and I want to connect to this network over here. I need to go to a router, and this router will go back to that switch there. Okay, hopefully that makes sense. Clear as mud. All right, a MAN, a metropolitan area network. That's a group of connected LANs in a large geographical area. They're a little bit larger area. Okay, um, Solano College, that's a metropolitan network. Okay, you have probably that's segmented out a lot of different LANs. You probably have the chemistry lab, they probably have something, the business office have something, or whatever else. Large campus all together. Okay, a WAN is a wide area network, a group of LANs that spread over a wide geographical area. So this could be like in other cities and other, this LA and versus Chicago. You want the Chicago office, talk to the LA office and things of that nature. And then you have a MAN and a WAN often use different transmission methods than a LAN. Yes, because you're probably using fiber, you're probably using telephone lines or something like that to get that data across because you have so many miles or so far away to do that. And then you have your own little personal network. You got your little smartphone and your smart devices and things of that nature here. Okay, so we're looking. This is we're looking at a MAN and a WAN here. Okay, so this is a WAN. So you got the San Francisco office, then you got the Philadelphia office. Okay, both on routers. This line here is your WAN connection or your backbone. When we talk about the backbone, but this right here is really probably fiber or a pack bell or some type of phone cable because you're going from San Francisco to Philadelphia. Okay, so they're using a different way of sending that information across that far. Okay, and from there, your San Francisco office has an office in South San Francisco and downtown San Francisco. So they got, it's all segmented out as well. So you have a router here that's going to go to their main router at the main office. These computers are all on the star topology, and we go from there. Okay, so now we're going to talk about the OSI model. Now, the OSI model has 7 layers to the model. Okay, and I think it's on the, okay, yeah, it's on this slide here. Okay, so, but when you think about the OSI model, it's going to tell you how data is transported on the network. Okay, so think of it as like if you're mailing a package. Okay, so a person is sitting at their home computer here, or you're writing a letter and you're going to drop it in the mailbox. That's your browser. Okay, then on the computer, the operating system, you're going to drop the letter in the mailbox, which is the operating system. This line here is like your network cable. Okay, then the hardware is kind of like the postman picking it up. So you got the computer tower, and then from your computer tower, it's on the hard drive. It goes through the data, the cable, the network cable. It's going through the network cable right here, the network cable, and then it's going back to the other computer's hardware. Once it gets to the other computer hardware, then this operating system is going to open up the package and look at the data, and then it's going to send it back to the web server, and then the other person on the other end gets it. Okay, so as you read the book, it kind of explains a little bit better, but they use the analogy of like sending a letter. So the open system interconnection, that's what the OSI model stands for. It's just a reference model. I provided you a link for a video that'll go into a little bit more depth in how to explain, and it may sound a little foggy now, but just remember, it's a 7-layer model. And each layer has its own category. Okay, so the physical layer is the bottom. So once you have, I think it's on the next slide. So you got the physical layer, which is the physical hardware and everything else. And you got the data link, that's the network cable and how the stuff is communicating. Network and transport there. This is when you're on your Ethernet card and it's transporting the data. A session is when it's starting the handshake. The presentation and the application is what you see on the screen once it's done. One of the ways they think about the OSI model is please do not throw away. So think of this acronym because you may need to use it. And I think there's one from the top down, but physical is the bottom. So it's bottom up. So if I go to this next slide here, this is the physical layer of the OSI model. And this is what functions happen. So you have the World Wide Web, email, and file transfer. These are your different applications, okay? So the person is sitting at the top, and they will either send an email, or they're just trying to go to Google, or they're just trying to send a file. You're going to you're at the application layer of the OSI model. TCP/IP, these protocols operate at this level of the model. The presentation layer, when you look at the web browser page and things of that nature, you're going to know if it's a secure web page, which is HTTPS, or if it's a non-secure web page. Are you sending what type of mail? If you're sending mail, okay, we're going with this one here. If you're just doing a file transfer, is it going to be a regular file transfer or a secure file transfer? Anything with S usually stands for secure. So at the presentation layer, you're going to do this, and you're going to have this session, and it's going to communicate back and forth. And this is all happening at the blink of an eye. You're not going to be able to see it or whatever. It's just a theory of what's going on. So just think of it as the philosophy behind it. This book can get a little deep, but it's really not that hard. Then once it gets the session and everything all established, it's going to start transporting across. So that's when the transmission control protocol is being used, or the UDP. Okay, so it's going to use these transmission protocols here, and then at the network layer, it's going to either use the internet protocol or the ICPM protocol or the ARP protocol. So it's going to decide which way is the best way to transmit this information that was requested above. Once it decides on the best way to transmit that, then it goes to the data link layer. It's going to go down to the network card and the hardware and the physical layer, and it's going to send that data out, and here in the transport layer, this is when all the packets and all that kind of stuff is going to be created. Okay, so the application layer describes the interface between the two applications that are separated by the computer. The application layer protocol are used by programs that fall into two categories. It provides a service to the user. We talked about the browser or the web page. The utility program that provides services to the system, such as the SNMP, that monitors and gathers information about the network traffic. Okay. Then you have a payload, data that passes between the application and the utility program on the OS. Okay. As you guys read the chapter this week, it'll come a little bit more clearer to you. Okay. The presentation layer is responsible for reformatting and compressing and encrypting all the data and then making it readable. So it's going to break it down on one side. It's going to encrypt it and put headers up on. And then when it gets to the other side, it's going to put it all back together so you can read it. So every time you click on another tab on your web page, if you're on Yahoo's main page and you see a link and you click on that link and it goes out and it gets that information, it brings it back to your computer. It's doing all of that in the blink of an eye. Okay, so so here's an example of a message, an email message. It can be encrypted in the presentation layer by the client of the OS. The session layer describes how data between the application layer is synchronized and is sent if the message don't arrive by the application. It's worrying about the session. Did you get the message? No, I did. Okay, let me send it again. Did you get it? Okay, you got it. Okay, good. Now I'm gonna send the rest of it. The application and the presentation and the session layer, they all work together. It's happening so fast. It's so fast. But just in theory, and keep in mind, this is just a model. But you need to kind of understand it. Okay, I can't emphasize that enough. And like I said before, it's often very difficult to distinguish between the two or what's happening at what given time. Most tasks are performed by the OS when the application makes a API call to the OS. The application programming interface, which is the API, calls the method of an application used and it makes the request to the OS. Okay. Transport layer is responsible for transporting the application from one payload to another. Okay. And the two main we talk about transport is the transmission control protocol. It makes the connection to the end host. It checks whether the data was received, and if then it orientates the data how it was. And the user datagram protocol does not guarantee it. So that's a lot of times why we don't use UDP, because you don't know if it got there or not. A lot of times UDP is used for file transfer and a lot of small stuff, but stuff that you want to be sure, most times the computer is not going to send it that way. Protocols add their own control information to the area at the beginning of the header. And like I said before, it's going to put their own information at the beginning so it can know on the other end how to put it back together. Encapsulation is the process of adding a header to the data to inherit it from the layers above. Transport layer headers addresses and receive applications by a number called the port. So everything on the computer communicates on different ports. And as it communicates on different ports, that's how we know to send it to the right location. And if the ports don't match on one end to another, data would not communicate. If a message is too large, TCP divides into smaller message segments, and then it sends it on its way. Then once sends nothing too big and choke the network down. The network layer is responsible for removing messages from one node to another. Okay, the IP adds its own network layer header and segment to the datagram. The entire network layer message is called a packet. So once it puts everything together, it's going to put these packets together. And if you do a ping, it says if you ping an IP address, I'm not sure you guys know what the term is, but if you ping an IP address, it's going to say how many packets were sent, how many packets received, how many packets were lost. So that's what's happening at that level. The IP address assigns to each node on the network. So every computer, like I said before, or node, which is considered a computer, every one has its own unique IP address. Okay, stop it. Okay. What's going on? Okay. IP relies on several routing protocols to find the best route. So it's going to find the best route. You wonder how, and it's amazing how fast data transport. I can send an email right now to everybody in the class, and you guys will get that email under 30 seconds. And you can, some of you guys can be in other states, some of you guys can be in other cities, and you guys pretty much will get it all in just about the same amount of time. So this is amazing how fast data is transported through these mechanisms. Okay, so layer 2 and layer 1 are responsible for interfacing with physical hardware of the layer. So this is where the computer is, the NIC card is, and the hardware that you plug in the cable and things like that on the network. That's at the layer 1 and layer 2 level of the computer, the PC itself, the network card, and the cable. So you have different types of networking hardware and topologies, and we talked about the Wi-Fi, for example, or Ethernet. Those are some of the two most popular ones. Uh, the link layer puts control information in the link layer header at the end of the packet of the and then it puts them on the trailer as well. So, and they call that frames. So, and like I said, this can get a little deep, but I'll try to keep it as light as possible. Now, a lot of you guys have heard of the MAC address. The MAC address is a physical address for each network card. Every computer, whether you have a physical network interface card on your computer, or if your computer has an onboard network card, um, there is a physical address assigned to that. And it usually has, I think it's going to go more into it later, but there is a physical address for it. I'll point it out later. The physical address is a simple layer and is responsible for sending bits via a wire or wireless transmission. Okay, so in the transmission, over the airways or through the voltages, low voltage copper wire, and then you have light, which is fiber optic cabling. And I don't know if for any of the new students out there, fiber optic operates on light frequency. It's not no power. Okay, so this is just protocol data unit, PDU. It's a technical name for a group of bits that move from one layer to the next over the LAN. So you can just see how and where the PDU works and operate on layer 1, layer 2, layer 3, layer 4, or layer 7. So and you can always see this is where it layers on the OSI model. The book will go into this more. I'm not going to go too deep into that right now. So this is a quick summary of how things work on the OSI model when a browser reaches a web server. So you, like I said before, you got your computer, the application layer is going to flow down. You got your payload. It's going to go down. It's going to create a section. It's going to break things up in a package. It put an H on it, which is the header, and that's going to come down right around the transport layer and things of that nature. And then once it gets the header, and then you got your trailer. After it gets the data physically, it's going to push it on through. Then when it gets to it goes through your switch here. Once it gets to the other side of the computer, it's looking at this. You got the HHAPT frame. Okay, it looks good. We're going to push it on through. It'll go through the router. It comes through the physical side again. It's checking. You go through the network, come down, blah, blah, blah. Then it gets to the web server. Then once it goes, and see, this is a switch. This is what your switch is doing in your house here. This is all your switch do. It's not as smart. But then once the switch, like I say, it's just pushing traffic through. But once it gets to the router says, okay, hold on. But let me double check to make sure I got all the packets. Okay, I got what I need. I got the header. Okay. All right, so now let me put that through. So the router pushes the packets through. And then once it gets to the web server, it's going to assemble everything back together. Network and computer technicians need to know how to protect themselves. So now we're just talking about the safety of computers. We're almost wrapping up this lecture. The safety of computers and working with computers. Okay, so know the best route for an escape. Basically, if there's a fire, this is a fire suppression system. We're talking about in the data center and how to be safe and things like that. The book kind of talks about that. Portable fire extinguishers and things of that nature. Suppression agents. Most data centers use a suppression agent to keep the the fire in a local area. We had a fire that broke out in a data center. Actually, it wasn't even a fire. We had a suppression system. You know, you have the overhead sprinklers. Well, in the data center, those overhead sprinklers probably won't put out water. It's going to put out some type of foam substance that will suppress the fire and make it go out. So I used to work for Sutter Healthcare, and a couple of years back, their suppressor system malfunctioned, and it went off in the data center, and it took down the company. It didn't take down one hospital; it took down 52 hospitals and a couple of hundred imaging centers. It was on the news. It was all over Sacramento. We were down for like I think a day and a half, and I know like 7 people got fired, and the CIO, he got fired. He was in San Francisco, had nothing to do with it, but because it happened on his watch, it rose downhill. It went from the top all the way to the bottom. So failover or fail close, does the security system allow doing a fire? So basically, if you have a failure or something like that, you want to make sure that your system fail over to a backup system. That's basically what they're talking about here. Um, MSDS, this we're gonna rush right over this material safety data sheet. Basically, in industry, once you guys get into IT and a lot of other industries, chemicals, or even at your school, or probably even in your chemistry labs and college and stuff like that, there's always an MSDS sheet there which talks about the different health effects of the different chemicals that are being used. That's all I'm gonna say on that. We'll move on. Electrical safety and tools are generally regulated by OSHA. Just keep in mind, OSHA is an organization that monitors a lot of, it's like a government agency that monitors a lot of stuff. PPE, personal protective equipment. And then you have to always use the right tool for the right job. I'm gonna pass over that. Um, lifting guidelines, always keep your back straight and things of that nature. We're gonna pass over that. Um, So we just go over to safety. That's one thing I do want to point out on safety is that with computers, and you don't see a lot of engineers do this any longer, but this is how you do it. You want to ground, this is a little grounding strap here. And he has this plugged into the chassis. Back in the day when I first started in the computers and the carpet, and you have so much static electricity, you can walk into an office. As soon as you touch a computer, you can short out the whole board and everything else. So you want to ground yourself there, these grounding straps, and they even have grounding mats when you're working on computer systems. And so you want to make sure you use that to protect the equipment and do it properly and things of that nature. A lot of times you find that computers are not in areas where there's carpet and static electricity. So you always want to make sure you ground yourself. Troubleshooting. This is one of my favorite parts of the chapter because I love troubleshooting because when you troubleshoot, that tells you how you really understand what's going on. So a lot of times when you're troubleshooting, and you can use some of these tips in anywhere in any class that you go, any job troubleshooting. But you want to identify the problem, gather information, look at the different systems. You want to question the user. A lot of times people say, "My computer's not working. I was at the hospital today. I got a phone call. I said, hey, my system's not working." That's all she said. Can you come down and fix it? I went down there and, it really wasn't nothing wrong with the system. But you want to question, what's changed? What were you doing when it happened? When the last time that it worked? Just ask some probing questions, okay. And then once you get those answers, then you just reverse, go back, and then you try to see exactly what they did and see if you can get things to work again. Um, Establish an action plan, implement solutions, and escalate the problem if need be. Always escalate the problem. Document your findings and actions and the outcome. That's really important too because you don't want to have to reinvent the wheel and do it again. Okay, and that is chapter 1. So let me stop the recording.